Okay, so I'll start by creating the dot network. I'll change the color to red and the shape to cloud. We actually have one. And let's dive inside. And we'll be using the new PyroSparse solver just so we can have a look at it. And it's very useful when you have big simulations. On this particular case, it's not the best situation where you would justify using PyroSparse solver, but it can still kind of speed things up a bit, hopefully, and it's going to be good for us to kind of introduce some of the different concepts that we have. It works pretty much the same way as with the default Pyro solver. It just has a few different things that we need to consider. So the first difference is when you start creating your smoke object, you'll notice that you have two options, smoke object and smoke object sparse. I'm going to create the smoke object sparse. And the main thing you'll notice is now we have this enable sparse solving. For the size of the object, I'm going to use the values that I used on my own simulation, so I don't have to manually configure this and figure it out. 1.2 and 3.2. And for actually, this is the size, so copy parameter paste values, and we'll copy parameter paste relative references. Make sure that the center is that the lower limit of the box is actually at ground level, and the center is going to be at minus 0.3 and minus 0.7. Okay, so now we have our smoke object. It's properly dimensioned, and let's move on to creating our PyroSolver. And again, you'll notice we have PyroSolver and PyroSolver sparse. Let's use the sparse one. Let's connect it to the first input. That's exactly the same. First thing you'll notice here on the PyroSolver is that we actually have gravity options. We don't need to add another gravity node. We already have some gravity options here. So let's connect this here. And we also need our source. Let's create our source, volume source. Same thing as before. Let's initiate this by choosing source smoke, and the path to the object is going to be source. The other difference is going to be that you have advection, sourcing, and forces. So forces are now the last input. So sourcing is going to be the third input. Let's keep things, everything as they are. Here on the PyroSolver, let's keep everything. And here on the smoke object, let's use the voxel size, copy parameter. Let's actually put this to 0.02. Let's go up. Here on our volume rasterize, let's kind of relate the resolution settings of our simulation to the resolution of our source. So I'll paste relative references and paste relative references, just making sure that the particle size, the particle scale is going to be slightly bigger than the voxel size. So I'll just multiply this by 1.2. And that way we have a particle size that's always slightly bigger than the voxel. Now, if we simulate this now, we should see something. We're not seeing. Okay. The one thing that I was forgetting is here on the volume source, you need to turn this on. Enlarge fields to contain sources. Okay, this makes sure that it's always tracking the source, and it will adapt, because by default it starts at this size, so it's not grabbing anything. And now we should see something. Okay, this doesn't look great, but it is our starting point for the moment. So first thing we notice is I want more density, definitely want more density. So here on the volume source, I'm going to multiply the density by 4. So a lot more density. I'm going to make sure that, as you could see, the smoke is actually rising a lot, and I don't want it to rise as much. So here on the PyroSolver, I'm going to bring the buoyancy down to 0.2. The gravity acceleration, I'm going to leave it for now as is, and we'll see how this works. So we have more smoke, and it's not rising as much, so it's actually looking better. Okay. The other thing we need to do is make sure that we tell it that it's this limit is actually closed. So as you can see here on the smoke object boundary conditions, this looks slightly different, but it's pretty much the same. So treat Y as closed below, and that way we'll have the smoke colliding with the lower end. Okay. We have our velocity working pretty well. Now, the next thing we need to do is make sure that the smoke doesn't disappear as fast. So here on the power solver, let's go to the shape section, and on our dissipation, let's bring this down a lot, 0.05. Okay, we're getting closer. This will change quite a bit once we have the, we actually introduce the collision geometry as well. So that's gonna that should have a big effect on how this our simulation looks. So let's have a look at how we should adjust that. Let's create our static object. So this is considered to be a static object because it's not going to be considered as affected by the dynamic simulation that's being solved. Okay, so that's why it's considered a static object. Even though it's going to be a deforming geometry, it's considered static because it's not going to be affected by anything that's happening on the simulation. So I'll say it's a deforming geometry. The saw path will choose the one that we created, out collision geometry, and that's pretty much it. Let's just merge this with our simulation. Now the order of the merge is also important. So this should be first, this should be second. And as you see here, a vector relationship, left inputs affect right inputs. You can change that, of course. You can change it to mutual. That also works. But this is a good way to work. Now, the other thing we need is for this actually to work. There are many ways of considering the collisions, but the fastest way is going to be through volume and the mode using a volume sample that we also created. So here on the section where you choose your proxy volume, that's where we're going to be putting our collision VDB. And this way you can have a look at, you can actually see the geometry here on the static. You can actually display the geometry, or you can display the collision geometry. And as you can see, what's being displayed is the actual VDB that we were generating. Okay, so let's see how this works now. It's looking interesting. Yep. Now, I think this is, we're on the right track. The next step is going to be for us to adjust some of the options that we have here on the shape, including the dissipation. We're actually going to be changing the dissipation to be controlled by the temperature. And this means that we can use this curvature and the variations on this field to establish where the dissipation should happen more or less. Okay, so what I want to do is here I want to kind of estimate the range of the temperature that I have. And let's say that my temperature is going to be, we saw that we had values of temperature going all the way up to 3, 4. So we should set it to that. Let's say 4. And what I want to do is I want to have the dissipation have more of an effect when we have lower temperatures and less of an effect when I have higher temperatures. Okay, I want it to dissipate more when it's kind of cooling down already. So the other thing I want to do is kind of tighten this a bit more. Yeah, something like this should give us an interesting result for the dissipation. And let's see how this works, how this looks. So the dissipation will only start actually being applied when the temperature goes below a certain value. Now we can increase the cooling rate if we feel that this isn't cooling fast enough. Okay, as you can see, it continues to rise. Let's actually create a camera for this. Something that I'm gonna go all the way out. Control, click on the camera. Something like this. I'm gonna focus on the tire. And that way we don't need to have a container for the simulation that's as big. I think this will give us an interesting look. whenever you want to preview your simulation, there are a few settings that we need to set up, a few things that we should set up to make it faster, or to make it more, to make it look better. Same thing as we've done before on the previous lessons. So here on the Burnout Sim, I'm gonna actually create a DOP import field. Let's put the DOP network there. Let's set the object to be the smoke object, but let's get its name. Smoke object sparse1, Control C, up. Let's grab that object. We want to grab smoke. I'm actually just going to start by grabbing just the density. Okay, so now we have grabbing that. Next, I'm going to create a volume visualization. That way I have more control if I need to increase the density field, we need to say it's density. And that way we can actually increase the density scale, the shadow density, etc. And of course, the other thing we'll need is some light. So I'm actually gonna create a light coming from something like this. I'll just use this light. And let's see how this looks. This Burnout Sim. Let's look through as you can see now we have shadows. So this is without shadows, this is with shadows, and we have a much better idea or reading of the actual shapes of the smoke that we're emitting. Okay, so now that we can actually see what's happening, and now that we have our initial setup, we can pin this and go to our network and start playing with the shape parameters.